The inverse square law says that intensity of the beam is inversely proportional to the square the distance from the source. In the equation, I represents the intensity and d represents the distance. Each variable has an original quantity represented as I1 d1 and a new quantity represented as I2 d2. As we can see in this photo, our original distance, which would be d1, is 1 meter. You can see one X-ray photon is hitting the image receptor. This is the amount of area that we can cover with our beam, as well as the original intensity, which would be represented as I1. Then, when we double the distance to 2 meters, it quadruples the amount of area that we can cover with the beam, which is why you see 4 times as many X-ray photons on the image receptor. But this also decreases the intensity of the beam to 1/4 the original intensity. When we increase the distance to 3 meters, essentially tripling the original distance, we can cover 9 times the amount of area, but decrease the intensity of the beam to 1/9 its original intensity. When we increase the distance to 4 meters, essentially quadrupling our original distance, we can cover 16 times as much area with the beam, but we decrease the intensity of the beam to 1/16 its original intensity.
If you are still having a hard time understanding the inverse square law, let's take a look at a concept that we may use in our everyday life so the next time you have to use spray paint for your home, you will be a pro. In physics, we are constantly using the inverse square law to know how distance will affect the intensity of the X-ray photons. So how does this concept work for spray paint? Let's find out. So the inverse square law says that the intensity is inversely proportional to the square of the distance from the source of that physical quantity. So you may be asking yourself still, what does this mean? So I have my spray paint, which is 2 inches away from the canvas, and as I am pressing the button, the paint comes out into the form of a circle. And as it hits my canvas, it's going to have some form of brightness or thickness to it, which I am going to call my intensity. So now what I'm going to do is move it back twice as far from my original distance, which will now be 4 inches, and spray some more paint onto the canvas. Now as you can see, when I moved back twice as far, my circle of paint is 4 times as large than the original one, but the intensity is less brighter than the original one by 1/4. This is because the paint is dissipated over a larger part of the canvas. So now if I move my spray paint 3 times as far from my original distance, which is now 8 inches, my circle of paint will be 16 times as large and my intensity will be 1/16 of my original intensity. Now I'm going to do this same concept at 16 inches and 32 inches. Now watch how my intensity is inversely proportional to the square of my distance. Notice how my original distance of 2 inches to 32 inches, the circle is much smaller at 2 inches than the circle of paint at 32 inches. But here is where intensity plays a factor into distance. As you can see, at 2 inches, the paint is much more intense, but as we moved back further to 32 inches, the paint became less intense. Thank you for your time to understand the inverse square law. I really hope this helped you understand how intensity is inversely proportional to the square of the distance from the source of the physical quantity.